Okay, today we're going to do the binomial theorem. We're going to use the binomial theorem to calculate binomial coefficients, use Pascal's triangle to come up with the coefficients, and then use these coefficients to expand the binomial. Just to refresh you, a binomial is two terms. When we expand these binomials, that means we're raising the binomials to a power, and we want to expand them. You should be comfortable with the first three. You've done those before, and you had anything raised to 0 power is 1, anything raised to the first power is just itself. And you learned this in Algebra 2 when you take the first term squared, second term squared, and then you double the product of the two. You've learned those three. These ones here, up until this point, in order to do like x plus y to the third power, you took x plus y, times x plus y, times x plus y, and then you multiplied these two, and then somehow distributed the x plus y to everything else. Today, we're going to learn a shortcut where we don't have to do all that work. We can just know what the coefficients are, know what each term is, and what power it's raised to. But first of all, I want you to look at these, and I want you to tell me what you notice. So pause the video. I'm going to pause it, and you tell me some things that you can recognize from the pattern of these binomials. Okay, I hope you had a couple of minutes to look at that. These are some things that you should have noticed that are pretty key to what we're doing today. First of all, if I'm raising something to the fourth power, I'll just start with 4. If I'm raising something to the fourth power, I have 1, 2, 3, 4, 5 terms. So I always have one more term than the number of power. So if I'm raising something to the fifth power, I'm going to have 6 terms. If I raise something to the 10th power, I'm going to have 11 terms. Your first, what I'm going to call my x, this x starts with the high, whatever power I'm raising it to. So this x is raised to the fourth power. And then the powers of x will go down. So 4, 3, 2, 1, and then technically raised to 0, so it's not there. And at the same time, the power of the y, or the second term, will be increased. So this will be y to 0, which would just be 1, y to first, second, third, and fourth. And then another cool thing is that if I add the exponents at any point, 2 plus 2, 3 plus 1, 4 plus nothing, you'll always get the whatever power that you're raising it to. And lastly, the coefficients, you should recognize the pattern. I go 1, 5, 10, 10, 5, 1. So they are a mirror reflection of each other. And so if I drew an imaginary line here, I have 1, 5, 10, and then 10, 5, 1. That's going to happen for any time we expand the binomial. And we're going to show you how we come up with those coefficients. This is the first way is you can do what's called the binomial theorem, which tells me that I do combinations. Combinations is something that you learned last year in Algebra 2 when you did your probability unit. Just a refresher, combination, you can write either two ways. So when I have this combination, this is red 9, choose 2. I can write it with a C, or I can write it with a parentheses. Those two mean the same thing. So to simplify it, I would do 9 factorial over 2 factorial, and then 9 minus 2 would be 7 factorial. So 9 factorial means 9 times 8 times 7 times 6 times 5 times 4. And 2 factorial is 2 times 1. 7 factorial is all this. And then what I notice is that the 7 factorial will simplify. The 8 and the 2 will simplify, and my final answer will be 36. So when I do 11 factorial, I'm going to try and simplify that a little bit. I'll have 11 factorial over 4 factorial. 11 minus 4 is 7 factorial. When I go to simplify this, I'm going to do 11 times 10 times 9 times 8. And then when I get to 7 factorial, I'm going to stop, and I'm not going to bother writing that all out because I have 7 factorial down here. And then 4 would be 4 times 3 times 2 times 1. I don't need to write the 7 times 6 times 5 times 4 times 3 times 2 times 1 because I know all that's going to simplify. Then I have 4, that would be my 8. And when I multiply it, I get 330. There are some cool ones. So like if I have 8, choose 0. So I have 8 factorial over 0 factorial. And then 8 minus 0 is 8 factorial. I realize that these 8's simplify, and I'm left with 1 over 0 factorial. Now that's not 1 over 0. 1 over 0 is undefined. 0 factorial is defined as 1, so this will just be 1. To give you a quick refresher on your calculator, if you hit menu, you go to probability, you're doing combinations. If I do, let's say the 11, choose 4 that we just did, I'm going to do 11, hit the comma, 4, hit enter, and that gives me the answer of 330, which I just figured out. But you're going to need to know how to do them by hand, but that's how you can do them with your calculator. Now let's talk about some special cases. If I have 10, choose 3, that would be 10 factorial over 3 factorial. 10 minus 3 is 7 factorial. When I do this 10 factorial, choose 7, that's 10 factorial over 7 factorial. 10 minus 7 is 3 factorial. You should realize that these two are going to give me the exact same answer, even though the denominator is written in the opposite direction. That's one of the reasons why my coefficients of my binomials are symmetrical, is because of this pattern where they repeat. If I have ones like this, 11 choose 1, this will be 1 factorial. 11 minus 1 is 10 factorial. So I'm going to have 11 times 10 factorial over 1 factorial, which is 1, times 10 factorial. The 10 factorials will simplify it, and I'm left with just 11. And then going the same way, I should recognize that 11 minus 1 is 10. So this would be 11 factorial over 10 factorial. And then 11 minus 10 is 1 factorial. So it's going to be the exact same work. So I will end up with the answer 11. Pascal's triangle is a way of doing combinations or coming up with those combinations without actually doing the combination, just continuing a pattern. So I'm going to write 2 rows of Pascal's triangle, and then I'm going to pause the video and see if you can come up with the next 2. So pausing the video, see if you can come up with the next 2. Okay, I hope you had a chance to come up with the next 2. The pattern is you start with a 1. Then you add the 2 above. So I'm going to add the 4 plus the 1 and come up with 5. Add the 4 plus 6 and get 10. 6 plus 4 and get 10. 4 plus 1 and get 5. And then I end with a 1. I see that symmetrical pattern where I have the 1, 5, 10, 10, 5, 1. It's like a mirror image in the center. Doing the next row, I start with a 1. Add the next 2 and get 6. Add 5 plus 10 and get 15. 10 plus 10 and get 20. 10 plus 5 and get 15. 6 and 1. So it's like every other row is going to have that special middle term that doesn't have a matching term, but then every other row will be exactly, the left side will look exactly like the right side. Another pattern that you should recognize is if I look at the diagonal, this 1, 2, 3, 4, 5, 6, I will see that it's just going to count up to the next one will be 7, then 8, then 9. So I always start with a 1, and then I go to the next number. When I ask you about a row of Pascal's triangle, this is considered row 0, this is considered row 1, row 2, and so forth. So this right here will be considered row 5. The second number, either inside, second to the last, or second number tells you what row you're on. So some of your problems have a question that says, use the 5th row of Pascal's triangle. So if I want the 5th row, I want the one that has a 5 as the second number. So if you can go back and look at Pascal's triangle, this is the 5th row of Pascal's triangle. It's saying use the 5th row of Pascal's triangle to find the binomial coefficients. So what I'm going to do is, this is to 6. So I'm going to start with a 1, 6, 15, 20, 15, ooh, that kind of looks 6 and 1. So what that means is this combination 6 choose 0 is that 1. Combination 6 choose 1 is a 6. And that pattern continues. Let's see. So that's how I find the coefficients using the 5th row of Pascal's triangle. Now let's start a baby one. I want to write the expansion of the expression x plus 1 raised to the 4th power. So my coefficients are going to be that 4th row of Pascal's triangle. So I can either write combination 4 choose 0 for my first coefficient, combination 4 choose 1, combination 4 choose 2, and I didn't leave myself much room. Then what I'm going to do is I'm going to take the first term, which is x, and the x will be raised to the fourth power. Then the x will be raised to the third power. X will be raised to second. X will be raised to first. And then x will be raised to zero power, which means it will just be 1, so I'm really not going to write anything there. Then I do the 1. So this would be 1 raised to 0 power, which would just be 1. This would be 1 raised to first, 1 raised to second, 1 raised to third, and 1 raised to fourth. If nothing makes, I'm going to start with plus signs and then adjust. So combination 4 chose 0. I'm going to choose to use the fourth row of Pascal's triangle. And just to remind you, the fourth row goes 1, 4, 6, 4, 1. That's the fourth row of Pascal's triangle. That's what I'm going to stick in here. So this will be 1 times x to the fourth, plus 4 times x to the third, plus 6 times x squared, plus 4 times x plus 1. So my final answer will be x to the fourth plus 4x to the third plus 4x plus 1. And so instead of actually taking x plus 1 times x plus 1 times x plus 1 times x plus 1, I've expanded the binomial using Pascal's triangle or combinations in the pattern that I just learned. So that's a baby one. Let's face it, raising 1 to the power is very hard. So let's go to one which adds a little bit of fun to it. So here I have -2 as my second term. So that -2 is going to do two things. I'm first going to have to remember to raise that -2 to a power. So it's not just going to stay 1. It's going to go like 2, 4, 8, 16, things like that. And then that negative sign is going to mean that I'm going to have to raise -2 to power. So to organize my work, what I might want to do is I might want to form a chart. So here's my first term, which is x. My second term is -2. Then I'm going to leave a row for my coefficient. My coefficient on the fifth row of Pascal's triangle, and you can go back and look on the fifth row of Pascal's triangle, and you have 1, 5, 10, 10, 5, and 1. Those are the I said 1 and 5. Those are the coefficients based on Pascal's triangle. If you don't want to remember Pascal's triangle, then you're doing a combination 5 choose 0, combination 5 choose 1, combination 5 choose 2, and so on and so forth. And when you do that in your calculator, you do it by hand, you are going to end up with 1, 5, 10, 10, 5, 1. Then I'm going to take this x, and I'm going to first start and raise the x to the fifth power. Then I'm going to decrease the power by 1 each time. When I get to this last one, I'm technically raising x to 0 power, but I'm just going to write 1, because that is what x to 0 is. Then second term does the exact opposite. I'm going to start with -2 raised to 0 power, which is 1. Then -2 raised to the first power, which is -2. Whoopsie, did it right where it said. -2. And take -2 squared, +4. -2 to the third, -8. -2 to the fourth, +16. -2 to the fifth, -32. Then to find what I'm going to do is I'm going to multiply down a column, and that's going to tell me my terms. So I'm going to take 1 times x to the fifth times 1, and I'm going to get x to the fifth. The next column, I'm going to take 5 times x to the fourth times -2. Well, the 2 times the 5 will be -10, because my coefficient will come first, then x to the fourth. Continuing my pattern, I'm going to end up with 4x to the third minus 80x squared plus 80x minus, oopsie, that should be 32, minus 32. Okay, let's do another one. So this one, I have 3 minus x squared. So I have a power raised to a power other than 1 inside my binomial. So I'm going to set up my chart. I'm going to give you a second to do that. So I'm going to pause the video. I want you to set up the chart and expand it. Okay, this is what my chart looks like. These are my coefficients of something raised to the fifth power again, the 1, 5, 10, 10, 5, 1. Then I've raised the 3 to the fifth power, the fourth power, the second, the third, and so on and so forth. Then I take this -x squared, raise it to 0 power, and then increase the power. But this is x, -x squared raised to the first power. This is -x squared squared. This is negative x raised squared to the third power. We don't actually get this one right. Negative x squared to the fourth power. So remember, the raise of power to a power, you multiply the exponents. Even powers, the coefficient becomes positive. Negative, our odd powers, it stays negative. And then here's my final answer. So pause the video, make sure you got that right answer, and we can move on. That one we're not doing. Okay, this one, find the fifth term. Now this is where people kind of run into trouble. So when you first start doing this, I know if I want to find the fifth term, so the first term would be this a to the 8th. Are you with me? And then 2b to 0. I'm just going to focus on the 8th so I can figure out what I'm doing. That's the first term. The second term would be a to the 7th, a to the 6th, a to the 5th, a to the 4th. 1, 2, 3, 4, 5. So I'm focusing on this one right here where I have a to the 4th power. So I have a to the 4th power. If a is raised to the 4th power, that means that 2b has to also be raised to the 4th power because they have to add up to 8. To find the coefficient that goes in front, I'm going to do combination of 8. I'm going to choose, and it's always the second variable, which is 4. So on my calculator, I'm going to do 8 choose 4, and then I'm going to have to remember, so on my calculator, I'm going to do 8 choose 4. So menu, probability, combination, 8 choose 4, or I could have written the first 8 rows of Pascal's triangle, and I get 70. So this is going to be 70. This is going to be a to the 4th. That's not going to change. 2 to the 4th, 2, 4, 8, 16. That's 16b to the 4th. Then I'm going to multiply to find the fifth term. I'm actually going to have to multiply this 70 times the 16. I get 1,120, I hope. A to the 4th, b to the 4th. A quick way to do this is whatever term I want, the fifth term, the second variable is always 1 less because I start with 0 and then start counting up. So the next one, I want to find the coefficient, and it just wants the coefficient of this 2a plus 3b to the 8th power. This one kind of helps me because I have b to the 3rd. So this 3b was raised to the 3rd. This 2a was raised to the 5th. When I do my combination, I'm doing 8, this choose 3. So on my calculator, I'm doing 8 choose 3. Or I'm doing the third thing of Pascal's triangle. Oh, 8 choose 3. And I get 56. So this will be 56. Then 2, 4, 8, 16, 32. 32a to the 5th. 27b to the 3rd. And then I'm going to multiply 56 times 32 times 27. 56 times 32 times 27. And I get 48,384. So this is that is the term, but it just wants the coefficient, so my answer is just this, the 48,384. Okay, I'm going to have to pause you guys for a second, but I'll be back. Okay, one more problem. We're going to find the coefficient of the term that has a to the 4th, b to the 7th when I raise that whole binomial up to the 11th power. So it just wants the coefficient, but I'm going to bring the variables with me because it helps me do the work. So this a to the 4th, so that means that whole 2a has to be raised to the 4th power. And negative 3b has to be raised to the 7th power. Then when I'm going to do when I find the coefficient that goes in front of this term, I'm going to do a combination. I'm going to do 11 and then choose 7. So on my calculator, I'm going to do all the calculations. So on my calculator, I'm going to do menu, probability, combinations. I'm doing 11, choose 7, and I get 330. So this will be 330 to the 4th, 2, 4, 8, 16. That'll be 16a to the 4th. And then -3 to the 7th. I can't do that in my head. So I am going to do -3 to the 7th. And I know it's going to be negative, but you should be in the habit of putting it into parentheses just to carry that sign. And get -2,187. And then this is b to the 7th. Now to find my coefficient, I'm going to have to multiply the 330. So the 2,187 times the 330 times the 16, I believe. Yes, 16. And when I do that, I get 721,694. And then that would be a to the 4th, b to the 7th. The question just asking for the coefficient. So this would be my answer, 721,694. And that is the last problem. Here are the problems out of the book that you should work on, and then go and take the quiz. If you have any questions, remember to email me, and I should get back to you as soon as possible. Good luck, and I hope everything works out.